Hello there, and welcome back. What we're going to do in this video is write the equation of a polynomial function with real coefficients, so that part is important, real coefficients, that has zeros negative 4i, positive 3i, and 6. So the first thing to remember with a polynomial with real coefficients, if there's any complex zeros that contain an I, so either a plus bi or just bi, pure imaginary, its conjugate must also be a zero of the polynomial function in order to create one with real coefficients. So that means that negative 4i also means 4i is a zero. And if 3i is a zero, that means negative 3i is a zero. And since 6 is real, there is no conjugate to worry about there. So by the linear factorization theorem, we know that f of x is equal to, let's just go step by step through all the zeros. Negative 4i means that x plus 4i is 0. If x plus 4i is a factor. If 4i is a 0, that means x minus 4i is a factor. 3i corresponds to x minus 3i. Negative 3i corresponds to x plus 3i. And 6 corresponds to x minus 6. So now, to make it look like a polynomial, what we're going to do is multiply these factors out. But we're going to do so kind of strategically here. So if I look at the first two factors here, that's the factorization of a difference of squares. So I know that when we multiply that out, we're going to get the first term squared minus 4i squared, which is 16i squared. And that's x squared minus 16 times negative 1, which is x squared plus 16. So that means when I write my polynomial function again, I know that x squared plus 16 is a factor. Now let's look at these two. Same token, really. This is x squared minus 9i squared, which will turn into x squared plus 9. And then the other factor doesn't have any i's in it, so I'm just going to drop that down. And now to multiply this out, we are going to multiply these two first. Now that's just basically a FOIL problem. So this means that f of x is equal to, well, let's see. First times the first is x to the fourth. The outers give us 9x squared. The inners give us 16x squared, so that's 25x squared. And then the last times the last, 16 times 9 is 144. And that's all multiplied by x minus 6. Now we have a trinomial times a binomial. So what that basically means is that every term in the left-hand quantity gets multiplied to every term on the right-hand quantity. Now, to make this a little more systematic, we're going to take each one of these terms and multiply it by x. And then we're going to take each one of those terms and multiply it by a minus 6. So I guess it means I have to move my f of x there. That's okay. So f of x still equal to, so x to the fourth times x is x to the fifth. 25x squared times x is 25x to the third. 144 times x is, well, 144x. X to the fourth times the minus 6 is minus 6x to the fourth. 25x squared times the minus 6 is minus 150x squared. And 144 times minus 6 is minus 864. And then, not entirely necessary but always nice to do, is to write the final answer in descending order. So minus 150x squared plus 144x minus 864. And there is our polynomial function that has real coefficients. Notice, actually at this point you noticed we had real coefficients because the i's were gone. But this is our polynomial with real coefficients that has the suggested zeros, or the prescribed zeros there, 4i, negative 3i, and 6 as zeros.